All right, in this video, we're going to introduce the idea or the concept of vectors. So we're going to introduce the notation and some basic properties of vectors. Okay, so vector is a quantity that has got magnitude and direction. So it must have both of these. So examples of vectors are like velocity and displacement. In displacement, for instance, if you say an object traveled 6 meters or an object traveled 2 kilometers, that has got only magnitude. In order for it to be a vector, I'd have to say an object traveled 2 kilometers in the northeasterly direction, for instance. Then that becomes a vector. And then quantities that have got magnitude only are called scalars, and examples include temperature. So if you state the temperature, I can say an object has got temperature 25 degrees, for instance. There is no direction associated with that. You could mention the volume of an object. There is no direction associated with that. So those are examples of scalars. Now, so it's important to have the distinction between these two, because in our study, we're typically going to be coming across quantities that are vectors with quantities that are scalars. All right. Graphically, vectors, we denoted them as directed lines like this one. So for starters, we're going to be looking at vectors that have a straight line in nature. But later, we're going to look at vectors that may not necessarily be straight lines. In which case, when we start studying vectors of this sort, then that's when we need calculus. Otherwise, for these ones, with vector algebra, we should be able to get by without a problem. But once you got, change in direction as in one vector, then we need calculus. Okay, so our study is basically going to be in 3D space, which is called R3. So if you look at this diagram, for instance, this is the x-axis, that's the y-axis, that's the z-axis. Let's imagine that the sides of this cuboid, if this is 2 and this is 3 and this is 6, if this is our point, let's call it P. So the coordinates of P are going to be, the x coordinate is 2, the y coordinate is 6, and the z coordinate is 3. So it's going to be the coordinates of this point P here. So if you go getting to P, you go 2 steps in the x direction, you go 6 steps in the y direction, you go 3 steps in the vertical direction. Now, let's call the origin point O. So let's denote this O. We can define a vector OP, which is called the position vector of P. So OP is going to be this directed line like that. Okay, Now, since the coordinates of O are 0, 0, 0, then the vector OP, so we're going to start introducing that notation now. So OP is just a straight line, but if we do this, then this is now the vector OP, because like I said, this is denoting the fact that this line segment has got direction now. So once it's got direction, then we call it a vector because it's got direction and magnitude. So one way of denoting vectors is by using the column vector notation. So in this case, we would take the coordinates of P, say coordinates of P minus coordinates of O. So for the x coordinate, it's going to be 2 minus 0. Then we're going to have 6 minus 0. Then we got 3 minus 0. So these are the coordinates of P. This is the position vector of P. If we want to write it horizontally, then we can write it like this: 2, 6, 3. This is now a vector. So that is two notations for presenting vectors. We're going to introduce our third notation in a moment. Now, before we do that, let's talk about unit vectors. So a unit vector is a vector that has got magnitude 1. So magnitude 1. And unit vectors are denoted with a head. So A, for instance, is a unit vector, or U, etc. So once you see the head there, then you know that the length of that vector is 1. We have got standard unit vectors in 3D space along the x, the y, and the z directions. The unit vector in the direction of x is called I. So that's a vector of magnitude 1. So we call it I. Means this point here is 1, 0, 0. And then another unit vector in the y direction, that point there is 0, 1, 0. This vector is J. Then this point is 0, 0, 1. Then this vector here is K. Okay, so those are the standard unit vectors in the x, y, z frame. You can see that they are mutually perpendicular. That angle is going to be 90, that angle is going to be 90, and this angle is going to be 90. So going back to our vector OP here, we can write it. So remember, OP is 2, 6, 3. That's the x component. It's the y component. That's the z component. So that means in the direction of I, we got 2. So we can write this as 2I plus 6J plus 3K. So that gives us the third notation of vectors that we are going to use. We can use any of these three notations, and it is important to use these to denote your vectors and differentiate them from scalars. Now, there's something called the magnitude of a vector. So as we said, a vector has got magnitude. So that is the length of the vector. So the magnitude of a vector, let's use OP, is denoted using the absolute value signs. Okay, so that is going to be the magnitude of vector OP. Let's introduce a general notation. In general, if we have got a vector, suppose we call the x component of our vector. Okay, so let's imagine we called it OP the other time, so let's imagine this is vector A. Okay, and let's imagine that the x component we call A1, the y component we call A2, and the z component we call A3. So it means coordinates of this point are A1, A2, A3. So if we have got vector A defined as A1, A2, A3, or A1I plus A2J plus A3K, or the third alternative A1, A2, A3. Okay, then the magnitude of A, is going to be given by the square root of A1 squared plus A2 squared plus A3 squared. This is a simple consequence of Pythagoras, of course. So yeah, so that's going to be the magnitude of the vector A. So I think, yeah, so maybe we can end there. So in the next video, we are going to start looking at some examples. 30 minutes now, we can do some examples here. So in this example, we have got three vectors. Vector A is given by 7i minus j. Vector B is given by the column vector 9, 1 minus 4. Vector C has got x component 14, y component minus 2, and z component 2. Find the magnitude of A. So before we go on, we note that vector A is a two-dimensional vector because it's got only x and y components. This one is a three-dimensional vector. This one is also a three-dimensional vector. So magnitude of A, the x component is 7, the y component is -1. So this is going to be 49 plus 1 is going to be square root 50. This is going to be 5 root 2. Then the magnitude of vector b, for vector b the x component is 9, then you got 1, and then you got minus 4, so 9 squared minus 1 squared, it's positive 1, then minus 4 squared. So it's going to be 81 plus 1 plus 16, which is, so 81, 1, 16 is 98. So let's go to 98. 98 is 2 times 49 again. So it's going to be 7 square root 2. Then C, we have got magnitude of A plus B. So I'm going to write both of them. So first of all, I'm going to work out A plus B. I'm going to write both of them as column vectors. So A is 7, negative 1. So notice that as a column vector, we can write it as 7, negative 1, 0. Okay. Then B is 9, 1, minus 4. Remember correctly. So unlike matrices, so for vectors you can add vectors with different dimensions. So a 2D vector is a 3D vector, but we can add them by simply replacing the x component, sorry, the z component here by 0. Okay, so for magnitude of A plus B, so A plus B, so I'm going to write this as 7 minus 1, 0, plus 9, 1, minus 4, and then we take the magnitude. 7 plus 9 is 16, minus 1 plus 1 is 0, and this is negative 4. Then magnitude of this is going to be 16 squared plus 16. So it's going to be 16 squared plus 16, which means we can factor out 16 here. I'm going to square root 16, 16 plus 1. We're going to be 4 square root 17. So that's going to be the magnitude of A plus B. For the last example, we got 2A minus C. 2A minus C. 2A minus C. So first of all, we're going to multiply A by a scalar 2. 7 minus 1, 0. Then we're going to take away C. C is 14 minus 2, 2. 14 minus 2, 2. Okay, so we need to do the multiplication first. So that is going to be 14 minus 2, 0, minus 14 minus 2, 2. I'm going to do the subtraction. It's going to be 0. It's going to be 0 as well. It's going to be minus 2. So this is going to be magnitude square root of 0 squared. 0 squared is negative 2 squared. This is going to be 2. Right, in the next video we're going to talk about the dot product.